So I'm going to solve problems 8 through 10 next. First one, this is about an elevator. These elevators are the fastest in the world. They accelerate at 3.125 meters per second for 4 seconds to reach their final speed. What is their final speed if they start at rest? So I'm going to do that on a separate piece of paper so I don't mark up the original. Number 8. So here we've got we know that acceleration equals 3.125 meters per second squared, and we know that time equals 4.0 seconds. We know velocity initial equals 0 meters per second because that's rest, and we need to find velocity final. So again, here we're just going to put this problem together. So using this acceleration equation, then you can cross multiply. This times this equals this whole thing times the denominator here, which is 1. So 3.125 so that equals 12.5. And you can cross the seconds here and that exponent out because they cancel. Meters per second equals velocity final. Okay? All right. So the next problem is number 9 on the back, and that's asking about a child sledding down a hill with acceleration 2.82 meters per second. Her initial speed 0, final speed is 15.5. How long does it take her to travel from the top of the hill to the bottom? So here we're going to be finding time. So number 9 for this is number 9. You've got velocity initial equals 0 meters per second. Velocity final equals 15.5 meters per second, pretty fast. And then we have acceleration equals 2.82 meters per second squared. We need to find time. So we're, again, just going to set up the acceleration equation. 2.82 meters per second squared equals velocity final, 15.5 meters per second minus 0 over time, t. And that's our unknown, so we can cross multiply again. So you've got 2.82 meters per second so we've got 2. And to solve this, to isolate t, we can divide both sides by 2.82. Sorry, that's squared, right? Squared. So divide 2.82. Cross that out. So you just have t equals, looks like 5.49 seconds, right? Cross meters per second out, and then you have 1 second left, so you flip it up on top. That's your answer. Okay, number 10. It's a little more complicated because it's asking for an acceleration, but it's giving us 2 different types of units. It's giving us 100 miles per hour as your final speed, but it's giving us time in seconds. So this is miles per hour. We need to convert that to meters per second first. So let's do that, and then let's find out what the acceleration is. Okay, so number 10. 10. First, let's start with 100 miles per hour. I'm going to first work away on that hour to get it to seconds. So I'm going to get rid of hours. I'm going to go to minutes. 1 hour is 60 minutes. But I still don't have seconds, so I'm going to get rid of minutes and go to seconds. 1 minute, 60 seconds. Okay, so now I've got seconds, so we're good there, but now I'm going to get rid of miles. So if you remember, 1 mile is 1.6 kilometers. So I got rid of miles, but now I have kilometers, and I want to get to meters. So km and meters. So 1 kilometer is 1,000 meters. So that's going to give us 160,000 meters over 3,600 seconds. So that gives us 44.4 meters per second as our velocity final. Okay, but it wants us to find acceleration. So acceleration equals initial velocity, which is 0. Sorry. It gives final velocity, right? 44 meters per second minus initial, which is 0, over time, which was 4.541 seconds. And here you can cross multiply. So we've got acceleration times time. So we've got A. We don't need to cross multiply. Sorry. All you have to do is solve this thing. Forget it. So you've got 44.4 meters per second over 4.541 seconds equals 9.79 meters per second squared. And that makes sense because this is seconds and this is seconds, so you're going to multiply those. They're both in the denominator to get seconds squared. That equals your acceleration. There you go.